So, very briefly, there are three types of magnetism. First, we have paramagnetism, and this is when the susceptibility is greater than 0. So we will come to the type of magnetism where susceptibility is much greater than 0, but when the susceptibility is on the order of 10 to the negative 6, then we typically call this paramagnet, and this is a wide class of materials. A diamagnet, on the other hand, is one material which exhibits a susceptibility that is less than 0. So diamagnets actually oppose a magnetic field that is applied to it. And we see this in the case of the experiment of Andrew Graham in 1997, where he used a kind of magnetic effect to levitate a frog. But here we notice the diamagnetism of water, for instance. If you put a strong magnet on a body of water, the water will be repelled. Notice here, superconductors have at the best diamagnets. They repel all magnetic field. They specifically forbid any magnetic current from passing through it. Now, finally, we come to the last major class of magnets, which is the ferromagnet. And a ferromagnet is a material which is actually a paramagnet, but a very good paramagnet, i.e. it has a very large susceptibility. Susceptibilities on the order of 10 to the 3, for example, in the case of iron, pure soft iron. These ferromagnets actually exhibit their own magnetic field, even without an applied magnetic field. So the magnetic dipoles actually are aligned without a magnetic field externally applied to it. And of course, when a magnetic field is applied, then those grains, those magnetic crystallites that aren't pointing in the same direction as the magnetic field will then align in the magnetic field. And so the overall magnetization, the overall magnetic strength around that magnet will be increased for that period under that magnetic field.